All right, everybody, welcome on in. So getting into new stuff here. Let's see. So we just finished up our test. So we'll start off by talking about that, and then we will get into new material. So the way this will work, right, I looked at the scores. Many of you did well. Many of you might want to do better. Is there a question? Thought I heard someone asking a question. Okay, so the way this will work with the retake. So those of you who wanted to do a retake, all right, you can do a retake exam on this exam. There is not a retake exam on the final that you will take. I want to make that clear. No retake on the final, but you can retake this exam. So looking it over, I saw some of you who probably should retake it. Some of you might want to retake it. There are a lot of scores in the 80s. Here's what I'm going to say. If you got a score in the 80s, maybe you just live with it, right? It's up to you. You all have different goals. You all have different reasons for being in this class. And depending on what those goals are, it might be worth your time to retake it. It might not. So if you scored below 70%, my recommendation would be to retake the test. Okay. If you scored above 70%, then I sort of recommend, it's hard if you're right at 70 because that doesn't give you a whole lot of leeway room. You might go, I think I could get an 84 now, and that gives me more of a buffer in the class. So it has to do with a few things, right? Here's the calculation you should be thinking if you think you want to retake the exam. Do you think you'll do better next time? Right? There's a question because some students forget this, but it's in the syllabus. If you take the retake exam, that is your new grade. And so sometimes people take that sentence that I said, if you take the retake, that becomes your new grade. And they say, oh, well, I thought you meant only if I do better. But that's not what it says, right? What it says is if you take the retake, that becomes your new score, right? That's kind of a habit, So some people get into, we definitely see it at this age, where people will take a sentence you say and then they'll put a bunch of assumptions into it and say, well, I thought you meant under these conditions. You want to get used to just hearing what a person actually says and then going from that. If you take the retake, it replaces your original score. That means even if it's lower, it replaces your original score. Now, here's what I'll say. People who study for it almost never do lower. If you actually put in the time to study the things that you missed, you're probably going to do better, right? But you kind of have to earn the retake a little bit by doing the studying, right? So as long as you put in the studying, you're probably not going to do worse. You're probably going to do better. A lot of times a student that has they got an 88 on the test, you have the option to take the retake if you want to. But be aware, if you take the retake and you score an 82, that's now your grade. Yeah.
Not really a question. I got an 88, but I won't take the retake because the questions I got wrong, I don't think I'll do better the next time. I think if I take the retake, I'll just get the same result.
Right. So the comment, in case you couldn't hear it, was, and I just made up the number 88. I'm not trying to call out any individual, but he was saying, yeah, I got this score. I don't know if I can do better next time around, so I'll probably just live with it. And 88 is a pretty good score. That makes it definitely still reasonable for you to get an A in the class overall, especially if you're doing all the homework. With the homework, you're probably sitting in the 90s, so just get a good score on the final and you'll be fine. So you don't want to risk getting a lower score. Now, what I will say is I do have office hours. So if anyone wants to come to my office hours and go over particular problems, I'm happy to do that with you. So we can discuss certain problems and look at them, but it's totally your choice. If you got a reasonable grade that you can live with, it's totally reasonable as a student, especially this time of year, to go, I don't think this is something I want to spend time on. You have to be strategic as a student. Part of being a student is being strategic. People think it's just going into classrooms and memorizing everything the teacher says. It's not. Sometimes you have to be strategic in, should I drop a specific class? Right? And I'm not recommending that anyone drop the class, but that's that's a strategic thing you have to think about. Will I do better in these other 4 classes if I drop this one? Is it worth my time to do this retake? Or I know I have this essay that's coming up due in my English class. I probably need this week to work on my essay in English and not retake an exam in math, right? So it's a different calculation for all of you. You are welcome to come to office hours, and I'm happy to go over any problems from your test that you want to take a look at. Happy to do that. But by all means, if you're happy with your score, great. But you don't even sweat it. Just move on and focus on your other classes and the homework in this class and that kind of stuff, and make sure you're ready to do the final. If you got in the 70s, you might consider it. If you think you can do better, if you think you can raise that score, give it a try. If you scored below 70, spend a week studying and then take the retake and then try to do better on it. So what I will probably do is open the retake later this week, so like Thursday, Friday time frame, and then you'll have a little bit into next week to work on it. So that gives you a little bit of time to think about it, but more importantly, it gives you some time to study, right? Because a common mistake I have, and this is why I actually have a waiting period now, because when I first started allowing retakes on some tests, I would have students that would go take it that same day. They get their test back and they're like, okay, I'm going to go retake it right now. Well, guess what they got? They basically would get the same score. So it's not really helpful. The idea here is that you need to spend a few days learning the problems that you missed so that you can get them right. You also should at least look at the problems you got right just to remind yourself how to do those problems, because sometimes I have students that they ignore the problems they got right, and then when they go to take the test, they forgot how to do a couple of those. So at least look at the ones you got right a little bit, but then really look at the ones you got wrong. And like I say, come to office hours and we'll take a look at it, right? We'll see what you did and what I can help you shed some light on the subject so that you can get them right the next time around. Okay, so come in, do that, get help. So I probably will release the retake Thursday or Friday, and it probably will be available to you into next week. Probably give you maybe a week to take it, when whatever works for you, but make sure you get it taken in that week, because I probably won't extend it past that. So make sure you get it done in that amount of time. But that gives you close to 2 weeks to study for it. Beyond that, the scores start to go down. I found over the years as I do this, if the students take it like right away in the first 3 or 4 days, the scores don't get any better. But if they wait longer than about like 10 days, the scores start to go down because you've forgotten a lot of the stuff. So there's kind of a zone in there that starts at about 5 days and goes up to maybe around 7 to 10 days where student scores usually go up. And I see students all the time, they turn failing grades into grades that are in the 70s and 80s. It just takes that extra work to get yourself up back where you need to be to get those scores in there. So again, totally up to you. If you have questions or concerns, or you're not sure if you should take the retake, come talk to me in office hours. We'll have a conversation about it, and then you can make the decision about whether you think it's a good thing for you to do or not. Okay, but this is one of your chances to raise your grade, right? I'm already getting emails from students about who are not necessarily in this class, but in classes, it's already kind of starting, even though we're a month and a half left in the semester. I'm already starting to get questions from students who said, this isn't exactly what they say, but essentially it's, well, I didn't do the homework, so can you give me some extra credit? And the answer is no. You have to abide by the rules, the way the class is set up. This is one option for you to improve your grade if you didn't like how your grade came out. So now is the time to strike. There won't be any extra credit at the end of the semester. Now is the time that you can improve your grade. If you did good, great, good work, right? Your hard work paid off. Give yourself a pat on the back, and you don't have to spend the week stressed out studying for a retake. Okay? So I think that's about all I have to say. That it's going to be a lot like the test. It'll basically just show up in the Delta Math. Here's what I'm going to tell you, and this is why grades get a little messed up, why it's sometimes hard for students to know their grade. The retake will show up for everyone, but not all of you are going to take it. But when I pull the grades down into Excel at the end of the semester, I go through by hand and I check those 2 categories to make sure that it's not hurting you. So you may see all of a sudden the retake is hurting your score in the Delta Math grades. Don't sweat that. It's not, just ignore it and go, I know I got like an 88 or whatever, so I know I'm doing pretty good. it's not gonna mess up your grade when I do the final calculation in Excel, but it'll throw it off a little bit in Delta Math. Because most of these grade books that are in these systems, even Canvas, the Canvas grade book for this class is a little messed up because of the retakes and stuff like that. So just ignore that. Okay, anyone who wants to talk to me about that, come to office hours. I'll explain everything you need about it, unless there's a question right now from anybody. No. Okay, so we're getting into, there's kind of a step up at this point, I would say. We only have what do we have? 4 chapters left? We have 4 chapters left. Chapter 3 is pretty short. We'll be through chapter 3 this week. One way or another, we'll be through chapter 3. And then we get into square root stuff. But the thing about the square root stuff is most of it is just watching the videos and making sure they make sense to you. So watch the videos in the Delta Math and the problems you're working on. And most people get the hang of how this works. 8 gets a little complicated, but we should be able to get through that in about a week. And then 9 is complicated. Yeah, nine's kind of a logarithms and exponential functions, especially logarithms. People just find that hard. So we do it at the very end, and we'll get to it. But we don't really have time to go super slow either. We got to move pretty quickly. Not rushing, but we have to move through things. So there's a step up in difficulty at this point. With rational expressions especially start to confuse people. Radical expressions, a lot of the chapter 7, the individual pieces are relatively straightforward, but some of these problems will involve you using like 5 or 6 different things from the chapter, and that can get a little confusing. So each individual tool is kind of straightforward, but when you bring all those tools together, it can get hard. And then 8 and 9 are just kind of a step up to more complicated stuff. We'll take a look at when we get there. Okay, so with that said, let's start our discussion on rational expressions. So this is my probability stuff from the morning class. Let's get rid of that. What is a rational expression? A rational expression is a fraction with polynomials in it. That's basically our definition. So you take a fraction, you put a polynomial in the numerator, you put a polynomial in the denominator. That's a rational expression. Now, at some point, we are going to deal with equations, rational equations. We actually have to solve equations. And like I say, we have like the first half of class went for the semester. From here on out, there isn't time for me to cover everything. So remember, don't just rely on what we talk about in class. We're only spending a fraction of time on these topics that I would if we were in class because we only meet 2 hours a week. So make sure you're watching those videos. Make sure you watch the YouTube videos. Make sure that I recommend in the sections. And then make sure you're watching the videos in Delta Math. They will help significantly. And come to office hours if you have questions, okay? So what's a rational expression look like? One way to help is the graphs become very important. So let's take a look at a graph of something like this. Let me move this over. Let's say the rational function or a rational expression is x squared minus 9 over x squared minus x minus 20. Here we go. Weird stuff. You can get all sorts of weird looking graphs from rational expressions, right? So they're not continuous anymore. Remember, like polynomials, we could draw them without lifting our pencil off the paper. Can't do that here. There's all sorts of weird stuff that can go on. Let's just change this one piece to a cube. A totally different graph now, right? So there's lots of complicated behavior we can get with a rational expression. Those of you who are going on to college algebra or pre-calc, trigonometry, you're sort of calculus bound, you're going to study these rational expressions a lot more in depth, and a lot more of the graphing features will make sense to you. But there's some basics we want to understand right now. Here's a big one. Remember one of the big things in math is you cannot divide by 0, right? And since a fraction can be interpreted as a division, that means you can't have 0 in the denominator of a fraction. Well, that's easy to see when your fraction is numbers like you've been used to. So if I write the number 2/3, that's a typical fraction that you've been dealing with since, the second grade or something. We've got this fraction. It's real easy to check if that's a valid fraction because I look at it and say, is there a 0 in the denominator? No. Okay, good. Then that's a perfectly legitimate fraction. That becomes a much bigger consideration when we have a rational function. And let me give you an example why. Let's take the rational expression x minus 7 over x minus 5. Is that big enough? That's kind of small, isn't it? Let's do this. Does that look better? That looks a little better, right? I'll make it small if I need more. If I need more room, I'll shrink it down. Okay, so consider these fractions. Consider this fraction right here, x minus 7 over x minus 5. So when I look at 2/3, I can see immediately, is 0 in the bottom? No, 3 is in the bottom, and 3 is not 0. Okay, what about here? Is 0 in the bottom? And I say, well, no, x minus 5 is in the bottom. But we're really concerned about the value of x minus 5. So is the denominator of this fraction equal to 0? And the question is sometimes. And that's where it gets to be kind of a pain. What do I mean by sometimes the denominator of that fraction is equal to 0? Well, what if x is equal to 5? Then in that denominator, I have 5 minus 5, and I get a 0 in the bottom. That's a problem. We're not supposed to have that. What if x is equal to 10? Okay, well, then I have 10 minus 5. That gives me 5 in the denominator. Yeah, that's okay. That's fine. That's a legitimate number, right? What if I get 0 in the top? What if x is equal to 7 and I get 7 minus 7? Is that a problem? No. Remember, when 0 is in the numerator of a fraction, that's totally legitimate. When 0 is in the denominator of a fraction, it doesn't make any sense. You can't divide by 0, right? Think about what division is. When you divide by a number, you're asking how many times did I have to add that number up to equal this thing. So, for instance, when we divide 6 by 2, I'm asking how many 2's does it take to get to 6? Well, 6 divided by 2 is 3. It takes 3 2's to add up to 6. It doesn't work that way with 0. The question doesn't even make sense. How many zeros do I need to add up to equal 6? Well, there's no answer to that question. So division by 0 is nonsensical, right? But it presents a problem for us with rational functions where we have this thing called domain. The domain is really wondering, when do we not get 0 in the bottom? When do we actually get a valid fraction out of here? 0 in the numerator is fine. 0 in the denominator, not allowed. In fact, if you notice in this graph, where was I? Here? Let's factor that expression that I have up there. So x squared minus 9. Let's factor that thing, and that's going to be what? X minus 5 over x plus 4. Okay, well, when am I going to get 0 in the bottom of this fraction right here? Well, when x equals 5 or when x equals negative 4. Let's graph those spots. X equals 5. Oh, look, x equals 5, right where this denominator becomes 0. That's right where I get this weird behavior in my rational expression. I wonder if the other one's like that. X equals negative 4. Oh, yeah, same thing. Right when the denominator of this fraction becomes 0, we start getting this weird behavior, this break in our function. Let me change these to be orange. So the orange lines are not part of a graph, but that's at x equals 5 and that's at x equals negative 4, precisely when our denominator becomes 0. That's where we start getting weird behavior in our rational functions. So it's not a coincidence. It's one causing the other. Okay. So getting 0 in the denominator of a rational expression is kind of a big deal, and we need to know where those occur. So you're going to see problems like, here's an example of a problem, undefined rationals, where they say, for which values of x is the expression undefined? Well, the expression is undefined when the denominator is equal to 0, And what's the denominator? X squared minus 16. So how are you going to solve this problem? You said x squared minus 16 equal to 0. You literally just take the denominator, set it equal to 0, and you go, how am I supposed to solve those? That's what last chapter was all about, is you learned how to solve x squared minus 16 equal to 0, right? And we'll see. The answer is 4 and negative 4 because it's the difference of squares. So when you solve it, you get that. And let's take a look. What exactly did they do? So what did they do? They took the denominator. They say, hey, set the denominator equal to 0, which is what I said. They set the denominator equal to 0. You solve that equation to get 4 and negative 4. And look, it's super easy to check. When you go back and you go, let's see, if I plug in 4, do I get 0? Yep, 4 squared minus 16 is 0. Negative 4 squared minus 16 is 0. So that's how you get those two answers. Okay, and they even give you an example here, or they're checking the work where they plug it in. So that's really all you got to do. Whenever you get to something where it talks about domain or undefined rationals, just think, set the denominator equal to 0 and solve. So 2 steps. Set the denominator equal to 0. Step 2, solve. All right, that's really all you got to do there. Simplifying. How do I simplify a trinomial? Well, how do we simplify a fraction? Like, here's what you should do in this chapter whenever you get stuck, is you should remind yourself, well, rational expressions are like this new thing that I'm learning. But my teacher keeps saying that rational expressions are just fractions with polynomials in them. And why do I do that? Why do I break it down as fractions with polynomials in it? Because you know how to deal with polynomials. That was the last chapter. And you know how to deal with fractions. You've been doing that since the 3rd grade, right? So the two pieces that make a rational expression, which are fractions and polynomials, you're familiar with. So that's good. So whenever you get stuck on something where you're like, I'm not sure how to do this operation, just ask yourself, how do I do it with numbers? And when I have more time in class, I literally do that. Like when we get to the rational expression part, I remind you, I do an example. Here's how we add fractions. And then we do the exact same steps with the rational expressions. Now, is it harder with the rational expressions? Yes. But is it the same procedure? Yes. Right? What do you do when you add rational expressions together? You find a common denominator. You add the numerators together. You simplify. Does that sound familiar? Yeah, because you've been doing that with regular fractions since the 3rd grade. It's just that here, the factors are a little more complicated. So how do we simplify a fraction? If I just give you the fraction 6/8, how do you simplify it? You think about the factors that occur in the numerator and the denominator, and you divide them out. That's exactly what we're going to do here. But there's a complication. If I give you the fraction 6/8, your brain is familiar enough with numbers that it goes, oh, 2 even numbers, they're divisible by 2. Let's divide the 2 out and go from there. Polynomials are new, so when you look at this, you don't know what the factors are. Why? Because it's not in factored form. So what you have to do, a lot of this chapter, step 1, is going to be factor everything in the problem. Like that's very frequently, that's what you do, factor everything. You're sometimes going to factor 4 polynomials before you even get started with anything, right? So we're going to do the same thing. I'm going to factor this, and we're going to divide out common factors. In fact, for the sake of time, because there's stuff I want to get through, I'm going to jump to the solution here rather than have me type everything out. Oh, let's see the solution. Yeah, show me the solution. Okay, so what did they do? They took, this was the problem, the original problem, and then they factored it, right? When in doubt in this chapter, factor stuff. See if that helps. So you factor it, but notice how the top factor has an x plus 9. The top polynomial has a factor of x plus 9, and so does the denominator one. That means they're in common, and you can divide them out, right? You can divide that thing out. This is the same as when you realize that 6/8 has a factor of 2 in the top and a 2 in the bottom, and you divide them out. That's what we're doing here. It's just that the factors are binomial factors, but don't overthink that step. It doesn't actually change anything. So you'll see one problem after the next. Okay, so what are we going to do here before I show you the solution? You're going to factor both of these polynomials. If they have something in common, you're going to cancel it out. Let's see if that's what they do, because of course it is. They got their polynomial. They factored it out. They canceled out the common factors. That's all you do every single time. They're all going to look like that, right? And then they've got a more complicated version. Actually, this is a slightly less complicated version. What would you do here? Well, it looks to me like everything here, well, you would factor the top, but it looks like everything's divisible by 2 and x. So it looks like I could cancel a 2x out of everything here. And that's what they did, right? They factored the top, factored the bottom, right? So factor everything completely. That's going to be like step 1 most of the time in this chapter. And then they said, oh, look at the 6 and the 2. I can cancel that to get a 3. And then look at the x and x squared. I can cancel that to get an x squared. You can't cancel with what's in here. You can cancel this whole factor, but like you can't. Here's a common mistake I see. People will say, well, here's the same symbol on the top and bottom. But it doesn't work that way. This 2 and this 2 can't be canceled. Why not? This 2 is connected by addition. This 2 is connected by multiplication. So to undo a multiplication, we divide. But up here, if you divide by 2, you can't undo an addition that way. So don't try to cancel those. I get a lot of times where if you need to think about canceling in terms of division. If you're thinking about dividing, you'll make less mistakes. For some people, especially if you memorize this stuff, canceling becomes more about drawing a line through identical symbols. So, well, I see an X in the top and I see an X in the bottom. I'm going to draw a line through those. It's like wishful thinking. I want these things to go away, so I'm just going to draw lines through them like you have a magic power or something. You have to keep in mind, we can't use wishful thinking. We have to divide. Divide the top by 3, divide the bottom by 3. Divide the top by x, divide the bottom by x, right? So you're dividing out. So just be careful about that when you do that. Okay, so that's kind of the simplifying of rational expressions. You just factor everything. You divide out the common factor. It's not super tricky. You'll have some evaluation problems. So they give you a problem like this. Determine the value of y if x is 3. I bet most of you already know what to do, right? Wherever there's the x, you're going to plug a 3 in there, and then you're going to simplify this thing. So if I plug 3 in the bottom, I get 7 in the denominator. 49 over 7 is 7. Right? You're just plugging that value in for the variable. It's not tricky. Okay, so those are pretty straightforward. Then, let's see, I've got about 20 minutes left. Yeah, let's get to multiplying and dividing, because multiplying and dividing is pretty straightforward. I'm going to be honest with you. Adding and subtracting, it's not fun. It's not a fun way to do it. Honestly, it's probably the least fun section in the entire course, right? It kind of sucks, which is what we'll do next time. Adding and subtracting rational expressions. We'll get to that next time. Today I want to look at multiplying and dividing. Not really that bad, honestly. So let's take a problem like this. I'm going to show you the solution on one and walk you through it, and then I'm going to do one so you can see me doing the steps step by step. Okay, so, I don't want to do a division one yet. Let's do multiplication first. I don't want a division. Let's see. It's not giving me an option for a new problem. Let's see. Let's go next problem. It's division. All right, give me a multiplication. Oh, here we go. Multiplication problem. Good. That's what I was looking for. If you can wrap your brain around how to multiply rational expressions, division is almost the same exact thing. There's like one extra step we have to do for division, and it's an easy one. And then you just treat it like a multiplication problem. So here, perform this operation. I want to multiply these. Now, there's a very reasonable thing that I see students do, but it leads to making things really, really difficult. And that is they go, well, I have two fractions, so how do I multiply fractions? I multiply straight across, and what they do is they multiply x plus 9 times this polynomial. That will make a third degree polynomial, which are even harder to factor. So we actually want to do the opposite. Instead of multiplying stuff in this regular form, we want to factor everything and then multiply it in the factored form. So let's look at it's giving me a division for the example. So let's look at the solution for this. I'll walk you through it, and then we'll do one together. So remember how I keep saying first step is almost always factor completely? Look right here, factor completely. So what you're going to do, we started with x plus 9 over x minus 1. Then we have these two polynomials over here. Hopefully you're very comfortable with factoring because you're going to be doing it a lot in this chapter. In fact, some of you who did poorly on the test, your factoring is going to get better just from doing chapter 6 on rational expressions because you have to factor so much. So they factored the top to get x minus 6 times x minus 1. They factored the bottom to get x minus 6 times x plus 1. Well, when we basically, like, in this step, I think they don't go over very well in the directions here, but sometimes we skip this step because it can just be confusing. Why is it that I can cancel a factor over here? Like, they basically get that everything cancels, right? Our x plus 9 here cancels with the x plus 9 here. X minus 1 cancels with this one, and the x minus 6's cancel. Everything cancels, and we're left with 1 over 1, not 0 over 0. Sometimes people think that when you divide things, you're left by themselves, you're left with a 1, right? So why can I cancel this x plus 9 over here with this one in a totally different fraction? Well, when we multiply, we just multiply straight across. So effectively, this becomes one giant fraction that has 3 factors in the numerator, 3 factors in the denominator. Okay, so that's why we're allowed to do it. The reason I point that out and make a big deal out of it now is because people try to do the same thing when we add fractions, but you can't do that when we're adding. You can't cancel factors in different fractions when we're adding or subtracting. Okay, not in the same way we're doing it here where we cancel this one and this one. So let's go to a better one. That wasn't a great problem. Let's do next problem. Here we go. Okay, so let's actually work through this one where the goal, factor everything first, factor completely. That's almost always the first step in this chapter. Factor completely. Then we're going to see what we can divide out. Okay, so let me see. I've got what? Let's come up with some stuff here. Was it x minus 9? X minus 9 over x squared minus 17x plus 72. So x squared minus 17x minus 72 plus 72. And then x squared minus 64 over 6x plus 48. Okay. X squared minus, was it 64? Yeah, and 6x plus 48. 6x plus 48. Okay, let's see. X minus 9. Okay, I'm checking just because this is another one of those chapters where students frequently will be doing the right thing, but they wrote the problem down wrong, and it's a bummer to spend 10 minutes working on something, and you go, I wrote down a plus instead of a minus or something. So you want to make sure you're careful. Okay, so step 1, factor everything. Okay, well, let's do that. Okay, so x minus 9 is already factored. Not much we can do with that. All right, x squared minus 17x plus 72. That seems to me like it's going to be, what, x minus 8, x minus 9? See, I'm just doing the factoring we learned last chapter. Okay, x squared minus 64, that's a difference of squares. So that's x minus 8, x plus 8. Okay. 6x plus 48. Looks like I can factor out a 6, leaving me with x plus 8. Okay. Now, here's the thing. Here's why we can cancel. Like what we're supposed to do here, I'm supposed to cancel this x minus 8 with this one over here. But why can I do that? They're in different fractions. Because our multiplication says we can just write this as one big fraction because inside the fraction, these things are going to be multiplying each other. So we can start canceling things out. It looks like everything cancels but this 6. But we've canceled everything in top. So what's left in top? 0 or 1? It's 1 because canceling is really dividing. When you divide something by itself, you're left with 1, not 0. So it looks like our whole answer, unless I messed up, should be 1/6. Okay, got it. So see, same thing I did. They factored everything. Start canceling things out. You're just left with that 6 there, so you get 1/6. So multiplying these rational expressions is not too bad. The steps are to factor everything. Find things. If you can find a pair where one's in the top, one's in the bottom, we can divide them out. Again, that only works when the operation here is a multiplication. We divide all that stuff out, and we get down to 1/6. Okay. So what about division? Well, what did we do when we divided fractions, right? This is one of those cases where I am going to go back so we can remember. If you had, say, 2/3 divided by 5/7. Oops, looks like I'm not on the right. There we go. How did we do this? Think back to your pre-algebra. What did we do when we want to divide fractions? And probably a portion of you right now are saying invert and multiply. And you might not even remember what invert and multiply means. But you remember, it's one of those things that people remember years later, like y equals mx plus b. And you go, what does it mean? You go, I don't know, but I remember the phrase y equals mx plus b, right? So what you do here, and some of you probably do remember, what you do here is you flip the second fraction and change it to multiplication. And someone usually asks, can I just flip the first fraction instead? Which I don't know why that's any easier, but the answer is no. You just try it. If you flip the first fraction, you'll get a different answer than if you flip the second fraction. So just flip the second fraction. You flip this one, change it to multiplication. So what we do here is this equals the fraction 2/3 times 7/5. Oops, typo, C dot. There we go. This becomes 2/3 times 7/5. That's what you're going to do whenever you get a division problem with these rational expressions. Convert it to a multiplication problem, and then do what we were just doing. So for instance, let's take a look at how this works in Delta Math. Let's see. I don't want to do another multiplication one, so I'm going to get a few wrong on purpose here. And hopefully the next one's a division. Here we go, division problem. So let me show you how they do that. So if we see the solution, see what they did right here? They took the second fraction and flipped it. So they say flip and change to multiply, which means flip the second fraction and the division becomes a multiplication. This is great because we just learned multiplication, so now you just do that, and then you get your answer down here. So they changed it to these, right? Then they factored everything. So they flipped the second fraction, changed it to multiplication, factor everything, and then look, the x minus 7s cancel, x plus 7s cancel. You're left with this 6, this x plus 5, and this x plus 7, giving you this. Okay? So that's really all there is to those. And I definitely do not want to get into adding or subtracting yet. That one's a bear. And in 10 minutes, 8 minutes, there's no way I'm going to be able to cover that in any kind of meaningful way that we need to get through. So we'll spend next time talking about adding and subtracting rational expressions. The multiplication and division, it's not what I'd call fun, but it's not terrible either, right? So I think what I'm going to do with the remainder of class is I'm just going to leave it open for anyone in Zoom to talk to me who wants to, so you can ask me any class-related questions. So I'm going to shut down the YouTube stream. Make sure you're getting caught up on the homework. If you're someone who's going to, that you're going to do the retake, don't wait till the test comes out to start studying for it. Go back, look at your test. I think you can still look at it. If not, let me know and I'll figure out which setting I need to change. But look at the problems you got wrong and see if you can figure out how to do them. And by all means, come to office hours and I will help you with those problems so that you can get them right on the retake. Okay? So that you can get those correct. So, so for about the last 5 minutes of class, I'll just hang out in Zoom, and anyone who wants to talk to me can do that. And then, of course, I have office hours today from 11 until 2 if you want to talk to me then as